Hi everyone, hope you had a good weekend. Hopefully you're not going insane sitting inside and doing nothing all day. And I hope that you can find some productive, good things for you to do. I have been knitting and trying to do like 20 minutes of working out a day or taking my dog for a really long walk. Hopefully you can find some simple things like that to do. I've also been watching the Star Wars movies one a night. I only have one left. So I'm going to need to start a new movie series, probably rewatching all of the Harry Potters. So I hope you're well. Please reach out to me if you need anything at all, if I can help you with something, or you just need somebody to talk to and vent to. I'm here for you. Just email me. Let me know what I can do to help. So we are going to start our lesson. It'll be really quick. It's something that you've learned before, so hopefully it won't be too long. I have posted the notes onto Instagram, and I'll put them onto Google Classroom as well. But what we're doing are the two types of bonds. So there are two types of bonds, ionic and covalent. There's also metallic, but you don't need to know about those right now. An ionic bond is a bond between a metal and a nonmetal. So if we're looking at the periodic table, this brown section right here separates the metals from the nonmetals. So everything over here is a metal, and everything over there is a nonmetal. Sorry for my horrible nails. I don't know what to do about them. Okay, so you have a metal and a nonmetal, and they come together, and what happens is they are transferring electrons. Meaning, like, if I have sodium and I have chlorine and they come together, sodium is going to give an electron to chlorine. And so that's something I've written in your notes right here. So sodium is in group 1, so it has one valence electron, meaning that it's going to transfer that electron to chlorine. So it's going to give its electron, its valence electron, over to chlorine. Just remember that the valence electrons are those outer shell electrons, so the ones that are found on the very outside ring. Then chlorine is going to accept or gain that electron. And since chlorine is in group 7, it has 7 valence electrons. When chlorine gains that one extra electron, that means it's completing its outside shell. So remember that the outer shell is sort of like the bonding shell of all atoms, and their goal is to get to 8. So any element that's going to be really close to 8, like those halogens in group 7, they have 7 valence electrons, they're going to do whatever they can. They're going to steal electrons from whoever to make sure that they can get to 8. Now, the other side of the periodic table, all of those alkali metals and alkaline earth metals, they actually are sort of just a lost cause. They only have one valence electron or 2 valence electrons, so they can't actually steal 6 electrons or 7 electrons from somebody else. So it's easier for them to give their extra electron, lose that complete outer shell, and go to their next inner shell. And when that happens, then they have that full outer shell and they actually become more stable. So what happens is when these when these elements get to these 8 electrons, that's like the holy ground. That's what everyone is working for, is 8 electrons. And when they get there, they become stable. It's like if I gave you a whole pizza and you ate all 8 slices, you would probably be full, right? You likely would not need any more pizza after that. Some of you might want it, but you'd be just fine having those 8 slices of pizza, or you'd be super full. So that's ionic, a transfer of electrons from a metal to a nonmetal. So the metal always loses the electrons, the nonmetal always gains the electrons. And remember, that's because on the periodic table, the metals tend to have less valence electrons, and the nonmetals tend to have more. So now we have covalent. So covalent is between 2 nonmetals. They share electrons, sometimes evenly, sometimes unevenly. So meaning, like if you have hydrogen and chlorine, they make hydrochloric acid. When you bring them together, they're actually going to share their electrons. So they form an actual bond, whereas in an ionic compound, they form poles. And I can try to find a good YouTube video that helps demonstrate that more if anyone's interested. But so the ionic form like a positive and a negative. Covalent, they just share. They are truly physically bonded. So in a covalent compound, let's say you have hydrogen and chlorine, sometimes they could be bonded evenly, meaning that the electrons are perfectly spaced in between both atoms. However, sometimes you might have the electrons lean more towards one side, and that's what we call electronegativity, which I'm going to talk to you about next. But for now, the most important thing, you need to understand how to identify ionic and covalent compounds. Now remember, an ionic is one metal, one nonmetal. A covalent compound is two nonmetals. Alright guys, that's it for now. I'm going to be filming another video in just a few minutes and I will upload it to YouTube. Good luck. Please let me know if you need anything and please do the assignments on Google Classroom. Miss you all. Bye!